Welcome to the Kubernetes Administration training. In this video, you will learn about the Kubernetes components and what components are Kubernetes uses and what are the relations between the various components. So let's take a look at the Kubernetes architecture. In the Kubernetes architecture, you will have one or more masters. You will find different components on a master. The Kube API server, it's the main component, and everything in a Kubernetes cluster will connect and talk to this API server. Other components like the scheduler and control manager are also deployed on the Kubernetes master. We call them as the Kubernetes control plane. Although we have another component which is not part of the Kubernetes core software package, the etcd key value store. We use etcd key value store to store every information about the Kubernetes cluster. So this is a main component. So this is a very important component in the whole cluster, because if you lose the etcd, then you will lose all the data about your cluster. You can use separate etcd cluster as well, but in the most common scenarios, you deploy it along with the Kubernetes control plane. So you will have communication over the local host, which is very fast. And if you have only one master, it makes sense to store everything on the master. But of course, you can use a separate cluster with 3 etcd servers at least to have quorum and high availability. But you can use it in this way as well. And if you have more masters, you can connect the etcd servers on each master to form an etcd cluster. Right now, just take a look at this configuration. So we have an API server, and you will communicate through the API server. It stores everything in an etcd. We have the scheduler. And when you deploy a new application on your Kubernetes cluster, the scheduler will decide where to start this application, on which node to start your application. The scheduler has a policy, and you can extend this policy as well. The controller manager will periodically check the status of your applications. We call them in a Kubernetes cluster as workloads. So everything which is an application is a workload. So the API server, scheduler, and controller manager, they are part of the core Kubernetes package, and you deploy them on the master server along with the key value store. Right now, only etcd is supported. Other important part of a Kubernetes cluster, it's the CNI network. The CNI network means Container Network Interface Network. This is a common interface for container runtimes like Docker, Containerd, Rocket, and so on, because you can use different container runtimes which are supported by Kubernetes, and Kubernetes is able to orchestrate it. The CNI network is a common network. It is an overlay or virtual network for your applications. Using the CNI network, you will provide a cluster-wide internal network for your applications and services, but this will be only available inside the Kubernetes cluster. But using the CNI network makes it easy to run all your applications on any node, and the applications are easily connected using this overlay network or rooted network. Whether you are using an overlay network with VXLAN or a rooted network with BGP or any other solution depends on the CNI network provider. The VNet, Calico, and other notable and famous CNI network providers using different methods. For example, VNet uses VXLAN, Calico uses BGP routing, and we have Contif from Cisco, and we have lots of other CNI network providers. They are compatible with Kubernetes because of the CNI interface standard. When you install a Kubernetes cluster, first you will install the master with a Kubernetes control plane along with a key value store. Then you will set up and use a CNI network provider to provide the virtual network for your applications. Then you will have nodes. In Kubernetes, we call them worker nodes. And the worker nodes will host 2 Kubernetes components. The kubelet, this is the main component on a Kubernetes node, because the kubelet will talk to the API server. So when you orchestrate your applications and when you want to acquire status and you want to communicate to the worker nodes to get the status of the applications, your network, the node, you talk to the kubelet, and the kubelet will talk to the container runtime, and it will report the status of the nodes, applications, and so on, the memory usage, CPU usage, network usage. So this is the main component on a Kubernetes node. And you will have the kubeproxy, which also communicates with the API server. The kubeproxy will do the filtering and traffic redirection using IP tables by default. So when you, as a DevOps engineer, deploy an application or issue commands to the Kubernetes cluster, you talk to the API server with the kubectl CLI tool, or talking to the REST API with Xcode, your own application. You talk to the API server, and the API server will get information from the etcd, or it will get information from the nodes with the help of the kubelet. But everything is connected to the API server. So, for example, when you deploy an application, you issue the command to the API server to deploy your application. It will store your request. Then it will talk to the scheduler. It will choose one of the nodes. The API server will connect to the kubelet. The kubelet will talk to the container runtime. It will talk to Docker, for example, if you use it. Or it will talk to containerd, runv, or anything else. And it will deploy your application and report back whether it succeeded or not, how is it started, and so on. And the status is stored on etcd as well. Also, the kubeproxy will get notified about the new application, and through the kubelet, it will know what is the local IP address of the application, what ports are allowed to use, and the kubeproxy will get the required configuration through the API server as well, what ports to open and so on, and it will set up the IP tables rules, and it will report back what is the status of the rules and so on. And later the controller manager will talk to the kubelet periodically to get the status of your applications. When a user wants to connect to your application deployed on one of the worker nodes, it will be redirected or allowed by the rules what the kubeproxy applied. You can also use user space proxies and not IP tables rules. So, for example, you can set up a reverse proxy or an application proxy. In this case, the kubeproxy will handle your request and forward it to the application. So this is how a Kubernetes cluster works. You have one or more master nodes. You will have several worker nodes, and you will communicate through the API server, and this organizes everything. And the kubelet is the main part on a Kubernetes worker node. In the training, you will learn how to work with different components of the Kubernetes cluster, how to deploy applications, how to order the scheduler, where to deploy your application, how to tell the controller manager the frequency of the checks, and what to do when your application fails. And you will learn how to work with the etcd as well, how to back up the data, and how to deploy even a Kubernetes master and worker nodes and the CNI network. In the next video, you will take a look at our training environment.